Welcome back, sixth graders, to lesson 78 in math. We are on page 377, and I need you to kind of follow along with the book, and if you have a whiteboard handy, you can do that too, you can hit the pause button as you're looking at the YouTube video and, look through the lesson itself as I'm talking about it, but you're going to want to practice this a little bit, and if you need to call again, please call me. It's important because this is getting in more into geometry as Cassie's filming these videos for me. And she just said, I just got done learning this, Dad, again with Mr. Chaddick. And so it was it's something you're going to be seeing as a 10th grader or a 9th grader. You're going to see these problems again and these geometric figures that we're looking at. So let's go ahead and get started. First off, I'm on page 377. And I kind of wanted to walk you through classifying quadrilaterals. All right, so it says that right there at the beginning, it says quadrilaterals are polygons with four sides. That's the very first statement that it states up there at the beginning. So we have quadrilaterals, which they list all these different quadrilaterals. All right, quadrilaterals are, let's try that again. Quadrilaterals have the most important part, which means four sides. That's the basis. Now, the next part of that is we have quadrilaterals of different shapes. So we have, first off, we have four-sided quadrilateral here that has no parallel sides, and it's called a trapezium. So if you notice, this is shorter than this, goes at a different angle, this goes at a different angle. There's nothing. It still is a polygon, and it's still a quadrilateral. So it fits the bill there, no problem. The second one, you have a trapezoid, which has one pair of parallel sides. So that means these two lines right here, this one and this one, are parallel to each other, and they would keep going on. But yet these two, if they kept going on, they would cross each other somewhere out in the future if they kept on going. So therefore, it only has one pair of parallel sides. And then the next one we have, which is a quadrilateral, but also what we call a parallelogram, which is going to be the foundation of several of these next four we're going to cover. It has two pairs of parallel sides. So we have one pair and we have two pair of parallel sides. That is a requirement to have a parallelogram. It must have two sets of parallel sides. All right. Now, notice I didn't say they had to be 90-degree angles or a form of 90-degree angle. Because if you notice in these first two, which we'll get to the rhombus here in a minute, they don't. But the last two you see for rectangular and square, they do. And so we'll get to them. So we have, again, the two pairs of parallel sides being a parallelogram. We also get down to the parallelogram with equal sides. Mouthful on that one, sorry. With equal sides. This basically means each one of these sides are equal, similar to a square, but yet they are not 90-degree angles. This one's greater than 90. This angle right here is, like I said, is greater. This angle here is less. This angle is greater. This angle is less. So those angles are all less than or greater than 90 degrees. And then the last two that we're going to look at are the ones that you're most familiar with, which is we have the rectangle, which is you have two sets of parallel lines, which are parallelograms, but yet also they have their 90-degree angles, which is more similar in shape. Go down to the square, same thing, all sides. Pardon the cruelty of drawing, but this is supposed to be a square. It's not a perfect square. Let's kind of fix that a little bit, make it a little bit more like a square. And then we have the 90-degree angle as well. So those are your basic shapes that are, again, quadrilaterals, and they are also polygons. Now, let's break it down to even further. Let's take a look at what the book's asking. If you notice that a rhombus rectangles are all parallelograms. So we have the rectangles and we have the rhombus are all rectangles. They're all one shape of those. Okay, now turn your book page over to 378. Let's kind of go through some examples of all these. We have, is the following statement true or false? All parallelograms are rectangles. All right, first off, a rectangle, remember, has to have that 90-degree angle in there, and we've already established that they don't. Take a look at these two parallelograms. They aren't. They are not going to fall into the category of all parallelograms are rectangles, because a rectangle has to have that 90-degree angle. So based on these two, that blows out the rest of the statement that they're asking, so therefore we would say this is false. And that's the reason it's false, because they don't form a 90-degree angle. Let's go down to the practice problems. It says state whether each statement is true or false. And we're going to walk through those all together. Instead of you doing it on the whiteboards, I'll do it with you. If you're working ahead of me, if you want to pause it right now and work ahead of me and see how you do, go for it. Do it. It's good practice. And then if you don't get it, I can clarify that. So this is a good time to hit the pause button and do those 5 practice problems and see how you do. Here's the first one. Letter A. It says all quadrilaterals are 4-sided polygons. So we got it in terms of quadrilateral. Here's a hint I gave you earlier. The term quad. So quad meaning 4. Okay? So that means all quadrilaterals are 4-sided polygons. That is definitely a true statement based on this right here. So it is true. The B, some parallelograms are trapezoids. Some parallelograms are trapezoids. Wait a minute, no. A trapezoid has one set of parallel sides. It needs 4 to be a parallelogram. It needs 2 sets of parallel sides to be a parallelogram. So in other words, take the rectangle square you're familiar with, 2 and 1 set, 2 sets. Here we have 1 set, but not the second set. Okay, so that statement is false. Let's go to C. It says every square is a rhombus. All right, so we have a rhombus, and it looks like, kind of, for those of you that are familiar with baseball, it kind of looks like a baseball diamond. Could look like a kite to you. All right, so it says again, every square is a rhombus. So if I take a square, and I take my little doodad little picture here that I have of things, and I'm going to slide this in and do the best I can to make a kind of a square. And if I take this, and it's not perfect, but we're going to forget about this top yellow piece. That'll be my handle hole. Here's a square. All right, so now it says every square is a rhombus. So if I take this and let's see if I can make it work. Kind of like so. Fasten that down. And let's see if I can make it like so. Come on. Oh, there we go. All right, there is my rhombus. So if I straighten that, it becomes a square. If I make it bend, it becomes a rhombus. So based on that definition of this little shape, I'll do it again. Square, square, and let's make it a better square than that. You know, Mr. White has that perfection side of him. You have a square, and still, I know somebody be saying, Mr. White, that's not quite right. I get it. Then if we bend it, it becomes a rhombus. Just like the shape here. Straighten it out, square. So therefore, that's a true statement. Every rhombus is a square. Well, let's take a look at this. This one right here shows it. This is not a 90-degree angle. So therefore, it's false, because every rhombus can't be a square because it's less than 90. But yet on the flip side, we said earlier, every square is a rhombus, because again, I started off with perfect equal sides. I changed it to a rhombus. If I make it turn, keep everything the same, I have my rhombus shape now. Square, rhombus. Therefore, every square can be a rhombus. But if I start messing with the dimensions of it, then it does not work. All right, so on the last one, some rectangles are squares. That is true. And we always dance around. I told you it was coming. Every square is a rectangle, but not every rectangle is a square. Because a square has to have equal sides. A rectangle does not have equal sides. So again, all squares, true. Yes, they are rectangles, but false if it's all rectangles or squares. That's the false statement. So again, A is true, B is false, C is true, D is false, and E is true. So, and that's basically what we're talking about. Again, if you have trouble with that, understanding that, give me a call. We'll chat over it. Your assignment is 2 through 30. You don't do number 1. And then, like I said, we'll be having the review test probably after lesson 79, which looks like it'll fall on Monday. So, any questions, feel free to call. Thanks.